we now introduce Markov chains. So let xn, where n is a positive integer, be a stochastic process taking values I1, I2, In, so on. So what does this mean? This means that xn is a bunch of random variables. So stochastic process means we have a bunch of random variables like this, and these random variables take on certain values. So say x0 takes on value I0, x1 takes on value I1, xk takes on value ik. So if xk is equal to ik, that xk takes on value ik, then you say that the process is in state ik. So currently the process is in state ik. So say currently the process is in state I, and then it moves to a state j. So this Pij will mean the probability of transition from current state I to next state j. So Pij is just probability from moving state I to state j. So I is the initial state. So you can write it like this. This Pij is your final state is j and your current state is I. You're moving from I to j. So all these states are in the past, x0, x1, x2, x3, all the way to xn minus 1. This is past. And here the probability just depends upon the current state and the future state. So it does not depend upon the past. So you can ignore this past here. So you just have I and j in the probability. You see I and j. So you can ignore this. So the above simply means that the future state xn plus 1 depends only upon the present state xn. The past states x0, x1 all the way to xn minus 1 can be ignored. So this particular type of process, we call this a temporally homogeneous Markov chain. So the future state just depends upon the current state. Past does not matter. Now we have said a lot, and let us see this in an example. So suppose that the chance of rain tomorrow only depends upon whether it rained today or not. So tomorrow whether it will rain or not just depends upon whether it rained today or not, and it does not depend upon any past days. So we are not depending on the data of past days. So this is like a temporally homogeneous Markov chain. We are ignoring the past data. Only current data, today's data is needed to predict tomorrow. So this is just a toy example. So you assign state 0 to no rain and state 1 to rain. So we first talk about P00. So P00 is the probability that it will not rain tomorrow given it did not rain today. So this probability you denote by alpha. So P00 you write like this. So P00, so 0 means no rain today. So this is T0 at time T0, no rain, and then no rain tomorrow at time 1 also no rain, 0. So this is alpha. Now if this is alpha, the probability that there is no rain today, so at time 0 there is no rain, but there is rain tomorrow. So there are only two states, rain or no rain. So this will be 1 minus alpha. And that's what we put here, P00 and P01. So this is alpha and this is 1 minus alpha. And P10 is the probability it will not rain tomorrow given it rained today. This is beta. So again we write it like this, P10. So initial state at T0, this is T1. So at time 0 it rained and time 1 it did not rain. So probability it will not rain tomorrow. So no rain tomorrow. So T1 is 0 given it rained today. So since it rained today, I have T0 as 1. So P10 is given to us as beta. So probability of 1, 1, that is it rained today, but tomorrow will also rain. This will be 1 minus beta because these two events are complementary. So these two events are complementary. So if this is beta, this will be 1 minus beta. Now from this single matrix like this, you can predict the weather n days ahead. So this matrix is called a transition matrix. So from this matrix, you can predict weather n days ahead. And this is nothing but a simple matrix multiplication n times. So that will give you the weather n days ahead. And this is justified via Chapman-Kolmogorov equations. So it is a big name, but it doesn't have much in it. You can see the proof in any textbook. And this is simply matrix multiplication. This is just careful matrix multiplication. So let us give a small example, and then you can inductively understand this n steps. So for example, say it will not rain 2 days from now. So you're given such a matrix and you are asked what is the probability that it will not rain 2 days from now, and it is conditioned on given that there is no rain today. So 2 days from now is this probability. You have, this is for today and tomorrow, T0, T1, and then T1, T2 is 2 days ahead. So notice that whenever you're going to do future probability, you should have this T1 common here. T1 is here and T1 is here. So these two should match. Now there are two possibilities. So since there is no rain today, T0 is 0. And there is no rain 2 days from now, T2 is also 0. But on day 1, there are two possibilities. Either it could rain or there could be no rain. So the first possibility is there is no rain. So no rain means that T1 is 0. So this T1 is 0 here and T1 is 0 here. So you can have 0, 0. Or you could have the possibility that it rains on day 1, there is no rain on day 0, rains on day 1, and then there is no rain on day 2. So that is T1 could take value 1. So the value is 1, 1 here. So P01 times P10. So again P00 is alpha. So this is alpha. P00 is again alpha plus P01. P01 is this 1 minus alpha times P10. P10 is beta. So this will give you the probability that it will not rain 2 days from now. And what is this? This is nothing but simple matrix multiplication. So we have multiplied this matrix with this same matrix again. So what we have done is we have taken this first row and multiplied it with the first column. That is it. That was our solution. First row with first column. So this is just matrix multiplication. So this is for 2 days. So you have multiplied. So if this matrix was P, you have gotten P square. So for 4 days you can do this inductively and you will get P4. So you set alpha as 0.7, beta as 0.4. So the probability of no rain 4 days from now, given it is not raining today, this will be given as P4. So you multiply this matrix by itself 4 times. So after you do it P4, what you have to just, step 1 is to compute P4. And in this P4, you will just select the entry right here in the first row and the first column. So let us compute this in R. And then we can see what is the value it comes out to be. So in R, the matrix multiplication, so P is this matrix. Matrix multiplication is just P percent times percent P. So this is just matrix multiplication. And since we want to find P4, we just find P square first. Then you multiply P2 with P2, you will get P4. And then we will just select the value in the first row and first column. So let us see this in R. So we have fed in the matrix. And now let us run this. So the probability of no rain is 0.5749. This is the probability of no rain 4 days from now. So that is our answer.